Hey everybody, it's Troy. Just wanted to do a little lecture today on virtualization. Probably going to divide the virtualization topic into a couple of lectures, just so that you have time to grasp the concepts and understand how this all fits in to managing a network. So the first thing we need to talk about is exactly what is virtualization. And it, most of you have dealt with virtualization on some level. You've used some type of virtualization on your PCs or your laptops, or maybe in one of the labs at UVU. So that is that's a form of virtualization. In fact, even um, the labs we're going to be going to a complete virtualization cloud type setup. So the first thing we need to do is define virtualization. Like I said, most of you already know a little bit about it and what it does, but if we had to put a real basic definition on it, virtualization is it's the act of creating virtual rather than actual. So actual being a physical machine version of something. This might be computer hardware platforms, server, PC, storage device, um, either some, and even some of the other network resources like switches, things like that. All right. Now, virtualization is not a new concept. It's been around since long before any of you were born. It started in the 1960s, and it started because of the mainframe computers, um, and it was a way that they could divide up space on the mainframe in a logical manner, so that they could host more than one application at a time. And since then, um, from that real big, expensive model of the mainframe, it's come down to where we're at today, which is a server-client relationship, and and then it's even gone further into the new uh, model, which is going to be the cloud client model. And if you think about it, the cloud client model is really a lot like the old mainframe model. You have computers that are doing all of the computing, the calculations, and the terminal or the computer that you're sitting in front of doesn't need to have the computing power, doesn't need to have the resources that the main machine does. So it's interestingly enough, we're going back to the original model in computing. We're just doing it in a different manner, but it's the same idea. So with with computers and with technology the way it is today, we have virtualization, and it's everywhere. When you go and you watch Netflix, when you go and you stream Hulu, you go to YouTube, Amazon.com, it doesn't matter. Wherever you're going, what you are seeing looks like just a regular website. And we know that websites are hosted on servers. So that the server that's hosting that website, or that is allowing you to stream a video, it's not a physical server that's doing that particular type of serving In other words, when you make a request and it serves you your answer, those are virtualized machines that you're dealing with. And there's really no way for you to know the difference between a virtual machine and a physical machine when you're logging in remotely. There's really no way to know the difference. And that's the beauty of it. So the first thing we need to talk about with virtualization would be a hypervisor. The hypervisor is by far the most important part of what's going on here. So we're just gonna make a little note here. Let's go over here, get our drawing going. Oops. Wow. Okay. That looked like I was drunk. So let me get rid of that. That was bad. So we have our hypervisor. And a hypervisor, there are two types. There's type 1 and there's a type 2. And that looks horrible. I'm just going to go to typing this out because this is bad. All right. Trying to use that as a whiteboard, and still a little bit of a learning curve there for me. So we'll hopefully you'll excuse that and myself a little bit of room to type up here. So a hypervisor, if you really think about it, that's the operating system for a host machine. And a host machine is a physical server. Okay? So if you there no matter what's happening, at some point somewhere there's a physical machine doing stuff. Okay? Even if you're using the cloud, if it's an on-prem, it's a hybrid, it doesn't matter. When you dig down, all the way down, there's a machine someplace. And so a hypervisor, that acts as the OS for your host machine. Now, it's not the OS like you're used to hearing about, like Windows 10, some dispo of Linux, Windows Server. This is a very specific type of OS that simply helps the machine to run and allocate resources and keep track of resource allocation. And it helps you set up the initial raids that you might have on this kind of machine, things like that. So generally hypervisor OSs have, they're what we call a very small footprint. In other words, they don't take up a lot of room on the machine. Most of these OSs are Linux based. They're Linux kernels because the Linux kernel has such a small footprint. Okay, so now there are two types of hypervisors. All right. Type 1. Type 1 hypervisor, this runs bare metal. Okay. Now, if you've never heard this term before, bare metal is what referred to as when a machine, it could be, in this case, it's going to be a server, but it could be a PC or anything else that doesn't have anything installed on it. There's no OS, there's the BIOS stuff, and that's it. It's bare metal. There's nothing on there. You have to put something on. Okay? So the bare metal, this is used at the server level. All right? And this there's a few out there that, there are. The one I used a lot was ESXi, and that's by that one is made by VMware. I know that there is. I'm trying to remember what it's called. Anyway, there's other versions. There's also Hyper-V, and that's the Microsoft version. And it used to be that nobody used this, but that's starting to change because Microsoft has finally figured out that they need to make some improvements on things. And Hyper-V is one of the things they're making improvements on. I know that there's several other Type 1 hypervisors. ESXi is probably the most popular. And then, like I said, there's several others. So we're not going to get into specifics of running each one and how to program them and all that. That's kind of a waste of time in the sense that I have no idea when you get out of college or if you're working right now, which of the flavors of this you're actually using. So you'll learn it on the job, but you need to understand the basics. Okay? All right. So then we have a Type 2. And a Type 2, this runs on a host machine. Actually, let's say it this way. This runs on a host operating system. Okay. So, the difference, of course, if type 1 is the OS, Type 2 runs on a host operating system. So the Type 2 isn't an OS, it's an application that runs inside the OS you already have. Okay, so before I confuse you too much, let's talk about some of these. Okay, so we have VMware Workstation. That's one that you guys have used a lot. I think it's probably, especially where you're students and you have a free license for Workstation Pro, probably the one you should use, just because it has many, many, many more features than any of the other ones out there do. And if you want to know what those features are, you can jump on with us in our Monday Q&A and ask me, and I'll run that down for you. But it's not really imperative to this. There's also the Hyper-V. Now, interestingly enough, Hyper-V is a different animal because when you run it on a server, you actually do run it inside of a Windows Server OS. Okay? Now, I know that gets kind of confusing, but that's the way Microsoft has set it up, which is one of the reasons a lot of people don't use it, because you still have a much larger footprint, and that's taking up resources. And you'll see why that's important in a second. So you have VM Workstation, you have Hyper-V, you have, let's see, I think there's one called VirtualBox, and okay, you guys get the idea. And this is the one that you guys use in your classes, where your professor says, okay, I need you to set up Wireshark. And so Wireshark, of course, can go on almost any OS, but you want to make your life easy, so you drop in you create a virtual machine on your laptop. Your laptop's running Windows 10. You open up Workstation, or VMware Workstation, and you create a virtual machine, and the OS that you put on it is Kali Linux. And now you have Wireshark. And so that machine, that new, or what we would call an image, is completely separate from your Windows 10 image. It's going to, when you open it and work in it, it's going to act like it is a completely different machine that you have. All right? And that's the cool part of it. Now, there are some things that these two types of hypervisors have in common. And that is that they share resources among the virtual images. Okay? So, no matter if you're running a type 1 or a type 2, the actual instances that you're creating are called virtual images. A lot of times, or virtual machines. You'll hear people call them VMs. All right? And those VMs have to share the resources of the host. So they share host resources. And so what do I mean by that? Okay. We'll get to that in just a minute. Hang on. No, let's do that part now. So over here, we have a virtual host. Gotta make this bigger so you guys can see it. Sorry. So, you're looking at a virtual host. Now, this is a server. This is kind of what they look like on the inside at a very basic level. And what you're doing is you're looking at from the top inside down into it. So like a bird's eye view with the lid taken off, all right, of like a rack server. So most servers today will have 2 CPUs. And the reason they do that is for virtualization purposes. Each of these CPUs will have any number of cores, 40, 20, 50. There's even some coming out now that have 60. They may already be on the market. They have 60 cores, all right? And then these little marks, and it got kind of tedious making them, so I just made a few. These are uh, RAM. This is RAM. These are RAM slots. And it's important to know this, that when you're looking inside your physical machine, you will have, at some point, there will be a divider or some type of a way for you to know that these slots are for RAM, or RAM for CPU 1, and then these slots over here are for CPU 2. If you put RAM into these channels that are for CPU 2, but you don't have a CPU 2, it's not going to do anything because it doesn't have anything to work with. Okay, so you have your two CPUs. Okay, and the two CPUs, and each one has 40 cores, and so that means that they have uh, 80 virtuals. So let's say you have 160 of the virtual cores. And then let's say that we have 256 gigabytes of RAM, and then storage, which is delineated by these. These are hard drives. You're looking down the top. So you have storage, and in this, so for this, let's say you have 1, 2, 3, 4, 5. You would have 6. There'd be another line there. 6 of those at, so let's say you have 36 terabytes of storage. Okay, so this is the important part. All of the virtual machines that you create have to share storage, RAM, and CPU. Okay? You can have as many virtual machines as you want on a given host, as long as you do not exceed what you have for resources. In other words, you cannot give what you do not have. There's the old saying, maybe it's too old for you guys, but you can't get blood from a turnip, meaning turnips don't have blood, so no matter what you try to do to it, you can't get it. Same is true with a host. When you have a virtual host, the only thing that limits you is how much and how much of these resources do you have. And then not only how much do you have, but how much is committed. And that's another important part. As you commit resources, it subtracts those from the total, even if they're not used. And that's where you have, that's where your hypervisor's coming into play here. And usually what you'll have is a dashboard, and it'll show you all sorts of different screens, but it will show you, for example, a list of all your servers, and then you can click on a server and you can see exactly what you've given each server as far as resources go. Now here's where you have to be really careful. RAM, it can be increased after you've created it. It can be increased or it can be decreased. I hope I spelled that right. Yep. Okay. CPUs, same thing. They can be increased or decreased. And this is after you create them, right? They're already up and running. You go through and you do a little audit on everything, and you find out, oh man, I'm kind of running out of RAM, and you see that you have a virtual machine that has 50 gigs of RAM on it. You're like, okay, let's do some checking, and you find that in its at its peak, it uses 4 gigs of RAM. Okay, well, now you can take 4 gigs of RAM and make that its standard, and you get 46 gigs of RAM back. You recover it. However, that does not apply to this, and that's the storage. You can increase it once it's created, but you cannot decrease it. If you give somebody 100 gigabytes in a hard drive, right, virtual hard drive, and they're using 10 gigabytes, you cannot lower their storage to be 10 gigs. Nor does your hypervisor take that into account. Once you have allotted a resource, whatever these are, then your hypervisor subtracts that from what's there. And it now says, okay, you have this much less. And you can actually see kind of a running count. Usually have it on like a little bar graph showing you how much you've used. They'll give you a number, like exactly you've used this much RAM, and then they'll give you a percentage of how much RAM you have used on your virtual host. The reason I point this out is this is a mistake that is really easy to make, and you want to be really careful in making it, because you can run out of space really quickly if you're not careful. And you will have people asking for more space all the time. And if you just gave everybody what they wanted, you would run out of space really, really quickly. Because on a virtual host, like I said, you can have a lot of servers. I had 2 virtual hosts in the office I was at, and each virtual host had about 45 VMs on it. So I had 90 servers. Think of them as servers. I had 90 servers that I was trying to run. If I gave each one of those the amount of space that they demanded, I wouldn't have 90 servers. I would have a much smaller number. I'd be forced to buy a new virtual host. And they're only about, I don't know, starting $30,000 plus software licenses. So they're a little expensive. So it's much better to manage your resources. So be judicious with all of these, and that's just good network management, but pay particular attention to the storage. When just a little piece of wisdom for you, when I get when I used to get a request for a storage increase, I would say, okay, how much do you want? They would tell me. Then I would go back to my network tool. Remember, we talked about the network tools? And I would go back to my network monitoring software, which was, in my case, the PRTG. I would pull that server up, and remember, I have a sensor that I put onto their hard drive, onto the C drive. I would pull their C drive, and I would take a look at what the past history of usage on the C drive was. And if the past usage was just, it was really straightforward, and then all of a sudden, overnight, they took up, 25 gigs of space, I'm going to go back to the requester and say, hey, look, so when you ran out of space, it happened all at once. What happened? and they'll explain it to you. Well, we had a big data dump, whatever it was. And then you can say to them, okay, is that data going to be staying? Or is this going to become a regular occurrence? And a lot of times what you'll find out is that these increases that they want, they really only need them to be temporary, which, as we've talked about, you really can't do. So you have to work with them to help them get into that machine and then delete out old data that they don't want so that they can free up more space. Even if they're developers, I guess especially developers that I worked with, they never think to go in and delete old crap out of there. And you don't need it if you're running backups properly, because that backup is kept and we archive backups as well. So anything that we're going to delete off of that machine to free up space, we have a copy of it. If they really need it one day, we can pull it up and get it for them. It's not a big deal. But giving them too much space is a big deal. Something else you should know, and that is that 80% of all VMs are over allocated. So 80% of every VM that's created, and this is industry-wide, has been given too many resources. And there are reports you can run depending on what software you have that will actually show you which machines you have that are over that have been over allocated. I'm going to pause for a second and pull up, see if I can find the chart that I have, so you can see what one of those reports actually looks like. Okay, so what we're looking at here is an actual report that I ran last year, in summer of last year, and it gives me some real valuable information. So, what it told me was, out of my 179 VMs that I checked, 118 of those were oversized. And then the CPU oversized VMs, there was 96. Memory, RAM, was 117. And then it shows you the resources that can be reclaimed, CPU and RAM. You notice it's missing storage. The reason they don't show you storage is, like I said before, there's nothing you can do about it. You just have to be smarter. But if you notice, it'll give me the name of every server. It gives me how many virtual CPUs it has, what it uses on average, which on this one is 0, and its peak usage is 1. So we can get 7 back. Now, if you go down here, this is the percentage, 1% of that. So that's you can't do fractions of a CPU. You have to do them in whole numbers. But as you look down this list, as I look down this list, I only see 3, 1, 2, and 3 that at their peak usage are using even close to a quarter of what we have allocated. Okay? Now, same when you come down to the RAM, somebody gave this 40 gigs of RAM. Now, I didn't create this server. This one wasn't in my office. Obviously, that's really stupid. And if you look at it, even in its peak, it barely used over 10%. So when you start to add these numbers up, if you go to, let's see, you can reclaim 240 gigs of RAM. Now, if you look up 240 gigs of server level RAM, that's a lot of money. You're talking about a lot of money. And that's why it's so important to learn how to utilize that's why it's so important for you to learn how to utilize the software. You learn how to actually allocate resources on them. You don't want to under allocate so that their servers are slow and you get complaints. But there is a middle ground, as you saw in some of those. There were times when the um, they had 8 cores and they only use 1. Well, okay, so you could give them 4 and that would still be okay, because you don't want it to be so slow that they complain. So that's it for this lecture. In the second series of lectures, we're going to discuss the benefits of virtualization, as well as what virtualization is doing now and what the future of it is. So thanks for joining me. I hope you enjoyed it. Talk to you soon.